Hello friends, welcome to Learner's Planet. Friends, in this session we are going to discuss Venn diagrams. Now what exactly Venn diagram is? For that we should be having the basic knowledge of sets, right? So first of all, let's discuss sets. I'll just briefly discuss over here. Sets are actually meaningful collection of data. Meaningful collection of data, right? The data that can be described, right? Suppose I can say set of natural numbers, set of whole numbers, set of positive integers, set of negative integers, set of real numbers, right? All of these are sets, okay? Because these are meaningful collection of natural numbers. This is meaningful collection of whole numbers. Similarly for positive integers, negative integers, real numbers, right? But suppose I tell you a collection of handsome people. People of say India, right? So it's not meaningful because what is the criteria for handsomeness? Okay, so that's actually not defined. So that's not meaningful. So it cannot be a set, right? So set is meaningful collection of data. Okay, set of suppose I tell you a set of your friends, your classmates precisely. Not even friends can be a meaningful collection because particularly there should be a criteria, right? Good friend, bad friend, which type of friend, right? So suppose I tell you set of all your classmates, right? Suppose you are in maybe third year, final year, right? So whatever the number of students are there, they will be making a set of and that set will be meaningful. Okay, so this is what set is, right? So set can be represented as this way. Okay, all the elements can be written as like this. Okay, similarly for whole numbers it will be 0, 1, 2, 3, right? Suppose for your classmates maybe N or maybe C, that's Ram, Sham, Sita, Geeta, whatever, right? So these are the some examples. Next is NA, right? Suppose I have a set A in that 1, 2, 3, 4. I'm having a set B where 2, 3, 5, 7, 9 and 10, right? So this is set A, this is set B, right? Now if I talk about NA, NA is number of elements in A, that's 4. NB, number of elements in B, that's 1, 2, 3, 4, 5, 6. Okay, after that we have a universal set where all the elements of A and B come, right? So we represent it as U. But all the elements will come for one time. See, 1 or 2 is repeated, 2 is there in A also, B also, but 2 will be written as 1 in only one time, right? So it's 1, 2, 3, 4, 5, 7, 9, 10. That is a universal set. Right? In universal set, all the elements of A and B will be written only for once, right? So U is the universal set and A is subset of U, right? Subset, that means all the elements of A are there in U, right? So A is subset, that is the sign of subset. A is subset of U, B is also subset of U, right? And this U is represented as A union B. That means all the data of A, all the elements of A and all the elements of B combine, when combined they get this. Okay, so it's called A union B, right? This is subset sign, that is union sign. Now next is A intersection B. Intersection means we have to take the common elements that are present in A and B both as well, right? So here we can see 2 is here also and here, 3 here and here, right? So in A intersection B we will be having only 2 elements, that is 2 and 3, right? Number of elements, union, subset and intersection. Okay, this is called intersection, that is common elements between the sets. Okay, now I introduce you with the Venn diagram. Venn diagram we used to present, it's a circular shape that we use to present the data, right? Here this circle is A, this circle is B, right? This portion that is common between these two is known as A intersection B, right? And this whole story, that is this and this, that the complete story is A union B. Okay, so if we have to find out the number of elements in A union B, what do we do? Number of elements in A plus number of elements in B minus number of elements of A intersection B, right? All the elements of A, that means in this circle, all the elements in this circle, minus this data, because while we are calculating this entire circle we have already included this. While we are calculating this circle we further have included this, that means this is included for 2 times, so 1 time we have to deduct. So finally you can by heart this formula, or you should be clear logically also. Okay, so and number of elements in A union B is equal to number of elements in A plus number of elements in B minus number of elements in A intersection B, right? Similarly, suppose I take this previous example where A is 1, 2, 3, 4, B is this. Suppose I wish to present them in the form of Venn diagram. It's A, it's B, right? Now 2 and 3 common, so I'll write 2 and 3 over here. Okay, 1 and 4, that's 1 and 4. Here 2, 3 we have already done. 5, 7, 9, 10. 5, 7, 9, 10, right? So if you are asked, 3 question can be answered. How many elements will be there in A intersection B? That's 2 elements. How many elements are there in only B? That's B minus A. That's actually only B. So only B is 4 elements, then N A minus B, that's only A. Only A are 2 elements. In A there are 4 elements, but only A, that means the portion that is not in B, that means this portion. Getting my point? So this portion is only A, this portion is only B, but this entire circle is B and this entire circle is A. In the entire circle of A intersection B is also included. Okay, it will be better cleared while we will be taking examples. Okay. Now friends, to elaborate this in better manner, what I do, I take an example. There are 95 students. Out of them, 40 play cricket, okay, 50 play football, and 10 cricket and football, both of them, right? Now, how do we draw the Venn diagram? That one circle is for cricket, one circle is for football. This is cricket, this is football. You will start filling the data from the center. That is the common portion. Now we have 10 persons who are playing cricket and football both. So I write 10 over here, right? After that 40 people are playing cricket. That means the sum of this circle must be 40. 10 we already have here. So here we'll be having 30. Okay. Similarly, the total of this circle football must be 50, right? 10 we already have here, so here it will be 40. Now you can answer various questions. How many people are there who play only cricket? These are 30. That means only this portion. Okay, only cricket. How many people are there who play only football? So only this portion, that's 40. How many people are there who are not playing any of the game? So this 40 and 30, 70. And 10, 80 people are playing at least one game, right? So out of 95, 15 are not playing any game. Getting my point? So it is so easy to answer. How many people are playing cricket? That means 40. But how many people are playing only cricket? That is 30. Okay? Just try to understand the difference between the two. Take one more example. In all there are 200 students total. Then out of them 100 play cricket, 125, they do not play hockey, right? Not play hockey, right? 50 students play both cricket and hockey. Okay, so let's draw the Venn diagram for this. Now here, this is circle of cricket, this is circle of hockey. Okay, 50 students play both cricket and hockey. I write 50 over here. Now 125 do not play hockey. That means out of 200, 125 are not playing hockey. That means 75 are playing hockey, right? So if 50 here it must be 25, because the total of this circle must be 75. That is, out of 200 students, 125 are not playing hockey. Okay, in cricket, total 100 people are there, 50 here, so 50 will be here. Now you can answer the various question. How many people are playing only cricket? That's 50. How many people are playing only hockey? That's 25. How many people are playing hockey? That's 75. Okay. How many people are playing at least one game? At least one game, that means 50 plus 50, 125. 125 people are playing at least something. That means 75 people are not playing anything. Okay, so you should be clear about each and every aspect. So once you have drawn the Venn diagram, after that all the questions will be very easy to answer. Getting my point? Similarly friends, we can have the problems based on Venn diagrams when three sets are there, right? So this is an example. Okay, it is set A, it is set B, it is set C. Now this portion is actually A intersection B. Okay, and this portion is B intersection C. Similarly, this portion is A intersection C. Now the most important is this portion. This is actually the common portion among all of the three, right? That is A, B and C. So that's actually A intersection B intersection C, right? Now we have the formula for number of elements in A union B union C is equal to number of elements in A plus B plus C minus number of elements in A intersection B minus number of elements in B intersection C minus C intersection A and plus number of elements in A intersection B intersection C. And what's the logic behind that? You have added all the numbers in A, B, C, but you need to deduct this data, right? That is being counted for 2 times. So we deducted that. But when we deducted that, this portion is also eliminated because this portion is also included in this circle and this circle. But this portion we have to take into consideration for once. That's why I have further added this, right? You can learn this formula or you can learn the logic as well. Okay. Now I take one example over here. Total is 240 people we are talking about in a company. Here English is spoken by 100 people, Hindi is spoken by 110, Telugu is spoken by 140 and English and Hindi is spoken by 30 people, Hindi and Telugu is spoken by 50 and English and Telugu is spoken by 50 and 20 people are there who speak all the 3 languages, that is English, Hindi and Telugu, right? Now we have to draw the Venn diagram and then we will try to answer the questions. Now what will we do? We'll draw the 3 circles first of all, right? That is Telugu, that is English and that is Hindi. And you will start filling from the center, that's this, right? English, Hindi and Telugu, 20 people are there, right? After that take this one by one. English and Telugu 50 people, English and Telugu, that means this portion must be 50, 20 is already there, that means 30 will be here, right? Be very careful. Hindi and Telugu 50. So Hindi and Telugu, that means this portion must be 50. So 20 here, 30 will be here. Okay. English and Hindi 30. Hindi and English 30. That means this portion must be 30. That is this portion. So 20 is here, 10 will be here. Right. Now come here. English is 100 people and 30. That means this total should be 100. Okay, circle of English should contain 100 people. So 30, 40, 50 and 60 is already there. So 40 will be here, right? Hindi 110, 30, 40, 50 and 60 is already there. So we are having 50 here. After that, Telugu 140, so 30 and 20, 50 and 30, 80 already there. So here we are having 60, right? Now this Venn diagram is complete. So if any time the problems are based on Venn diagrams, there will be definitely 4 to 5 questions, okay, based on this data. So once you have constructed the Venn diagram, after that it's very easy to answer the questions, right? The first question is, how many people speak only English? That's 40. How many people speak only Telugu? 60. How many speak only Hindi? 50, right? How many people speak Hindi and English? Hindi and English. So that's the common portion between Hindi and English, that is actually this, right? Be careful. 20 plus 10, 30. This 20 is they are speaking Telugu also, but they are definitely speaking Hindi and English both, right? So if you are asked how many persons are there speaking Hindi and English both, so it will also be included, right? How many people are for Telugu and English? This is 50. Already we know, right? How many people are there who are speaking only Telugu and English but not Hindi? So that's this 30, because these 20 are included in the circle of Hindi also. Okay, so only Telugu and English is 30, only Telugu is 60, only Telugu and Hindi is 30, only Hindi and English is 10, at least one language, that's the complete, the total. You add up all the numbers and you'll be getting the person at least one language, right? No, then you add up all the numbers and deduct it from the 240, then the remaining people will not be speaking any of these language, right? So that's pretty simple to answer all the questions once you are able to draw the Venn diagram, and how to fill up the data in the circles that I have already shown you. Okay, now we'll be taking some practical examples, so you'll be able to understand it in better manner. Okay, now let's try this question. Out of 100 members in a club who play bridge, billiards or basketball, 80 play at least 2 of the 3 games and 90 play at least 1 of the 3 games. Then how many members play exactly 1 of the 3 games? Exactly 1, right? Now first of all, 90 people are playing at least 1 game. That means 10 people are not playing any game, right? The first thing. And 80 are playing at least 2. And 90 are playing at least 1. That means if we deduct this from this, we'll be having 10 people who are playing exactly 1 game, because these 80 are included this in this also, because at least 1 in at least 1, at least 2 will also be included, right? Getting my point? So these 80 people are included in this also. So 10 people are there who are playing exactly 1 game. So no need to draw any sort of Venn diagram over here. Okay, by common sense also you can answer the question. So that's 10, right? For concept clarity, I'll draw the Venn diagram for you, so you should be clear once for all, right? Now what is happening? 3 games are there. Okay, that's bridge, billiards and basketball, right? Now 90 play at least 80 play at least 2 of the 3 games. Now in at least 2, 3 is also included. That means the person who are playing 2 games as well as 3 games. So that is this area. Okay, this region. So this total is actually 80, right? Then we have 90 people play at least one game. That means 90 people are there who are playing one game or two game or three game. That means sum of all these three circles inclusive of these is 90, right? This circle plus this circle plus this circle, even this green area is also included, that is 90, right? That means if the total is 90, we want this portion plus this portion plus this portion, that is the portion that is not covered by green, right? So entire portion minus the portion covered by green will be our answer, right? So the portion that is covered by green is 80 and entire portion is 90. So 90 minus 80 will give us only billiard plus only this bridge and only basketball. That is exactly one game. Getting my point? So I have shown you the diagrammatic representation also, but that is actually not required. For your concept clarity only I have done this. Otherwise by common sense also you can answer this question. Okay, I hope it's clear to you. Now we have this. Out of 50 members who play cricket, hockey or football. So 3 circles are there. Cricket, hockey, football. 5 play all the 3 games. So this total is 5. Now 30 play at least 2 games. At least 2, that means 2 or more than 2. That means they may play 2 game or 3 game, right? Out of which 20 play both cricket and football and 10 play football and hockey. How many members play only cricket and hockey? Now just watch carefully. See 20, we have already filled up this, right? 20 people play both cricket and football. So cricket and football, in all there are 20 people. So 5 here, 15 will be here, right? So that's done. Then 10 play football and hockey. Football and hockey, total 10 people are there. 5 is here, so 5 will be here. Now what it is telling, 30 play at least 2 games, right? That means sum of this area must be 30. That is 2 games and 3 games, right? So 15 and this 10, 25 is already there. So it should be 5. That means cricket and hockey is played by 5 members, right? How many members play only cricket and hockey? That's 5. If only is not there cricket and hockey, then 5 and 5, 10 will be there. But since it is only over there, that means these people should play only 2 games, exactly 2 games, and these 2 games must be cricket and hockey. So that's 5. Okay, so it's so easy once you are able to draw the Venn diagram. I hope it's making sense. Friends, in the next session, we'll be taking more problems based on Venn diagrams. Do revise this session before you come for the next session. Okay, bye-bye. And yes, one more thing to remind you that it's actually an important topic from your examination point of view, because at least 1 or 2 questions from Venn diagrams are frequently asked in various competitive exams. Okay, so be very clear about it. Believe me, it's very easy. You need to have some practice only. Okay, so I'll see you in the next session once again. Bye bye.